Hello and welcome. I'm Bill Wake. We're here working on the basic interpreter we developed a month or two back, and we've decided to make a change in an evolutionary design way. The old approach was to use recursive descent parsers, and the new approach is to use parser combinators, which are come out of the functional programming world. We've made a lot of progress on the statements. We really just have to do return on the list of all statements. And then we've got a few more of the parent callers to fix. But we are just about done with the statements here. So let's finish that for starters. All right. And end of day yesterday, we took a go at it. Let's see if I can find return. Well, that's too common of a word. Return, that's too rare of a word. Okay, let's find statement. Okay. Data parser, data dim, go to next, return. Okay, let's see, return statement. Okay, that's too simple. We need to inline that. Back to return. Result equals try. Well, next token doesn't really throw, so let's just return. How about result equals return? Give that a run on the tests. And the real thing is we wanted to do this. We did one-word statements, and I guess I just missed that one because it's a one-word statement. Okay, so inline refactor, inline return statement. Okay, let's find these one-word ones. One-word statement, one of this. Okay. Yeah, we did a quick run at this yesterday. We tried to add return, and this is going to fail. Or maybe, yeah. Okay. Basically, it's not finding the value in here. Okay, unexpectedly found null. All right. And token to simple statement. Yeah. So the return token maps the return statement. That should do it. Good. Let's see. This is add new return statement parser. Okay. And if can I go back? Nope. Okay. Let's find statement again. Okay. So now what we were doing, we've got data parser is done down here. Yeah, basically we're doing wrap new on these things. The ones that aren't, we just haven't inlined their parser yet. Okay, and so I think what I'd like to do is, well, in the end, we're going to try and do something that's more like, data parser or dim parser or one word statement, etc. Okay. but we're not quite there. All right. So I think my systematic way is we should find that all these parsers are the new way. Let's make sure that's true. Okay. So here's define. Let's inline it. In effect. Okay. Define. And at the end, it's result equals instead of this. Okay, and it should be all fine. Okay, let's find define. We just got rid of that. Okay, so what we did was refactor inline define. Well, go subs right here. Let's grab it. I'm gonna be a little quicker on the draw here and just do that. Somebody should be complaining by now. There we go. Go sub, inline that. Result equals. Go to. Result equals that. Inline the go to. This one's a little more intricate. Let's skip forward to do input. That one's, yeah. Input. Now, you're probably noticing this is one of those times we're making things worse before we make them better. Whoops. How are you now change? Okay. Next on print. Another one that's moderately big. Well. Oh, we had the old comments too. Rushing at the end. That's what happens. return. This one, I don't think we even need to do here. That should be covered by our one-word statement. Good. Delete redundant return. Case from statement. Okay, and I think that just leaves the if-then was the only one that we left out. If-then, okay. If-then, well, that's not as bad as I thought. Notice this one's recursive. It calls this method result equals. Inline if statement. Okay. Now, I think we're at the point, oh, we left out 4. All right, now, excuse me, I think we're at the point everything is, well, it's all referencing the new style parser. So def is definitely dim. Notice they're all doing wrap new. We're going to get rid of that. Okay, wrap new. Okay, on print. Good. All right. Now what I want to do is I want to pull these parsers up to the top because really it really is its own thing. Okay. So notice up here we've defined them and then we actually do the work of parsing. So I want to separate these two. And we got data parser. Let's pull up def part, variable part, and tokens. Okay, this one's a little bigger than average, but and I don't know, I might even leave a little space here. These may define parser was never used. Oh, okay. I just copied. Okay. So there should be no harm in moving it up since we don't change the parser once we create it. Okay, so move statements up. Okay, and there's a whole analysis I'm kind of implicitly doing for that. I mean, I'm taking advantage of the fact that these things are defined but never changed, and nothing references. There's no like aliasing where the same name gets used twice for two different things. If I had done like parser equals that and then try parser here and then start over parser equals that, define parser there, I wouldn't be able to do this because they would interfere with each other. But these statements, there's no harm in executing them regardless of whether I'm doing a for or whatever statement I'm doing. Okay, so I'm just pulling them up. The question I have for myself is like, do they? Even that is pretty big. It's the whole grammar in one big blob. Okay, and I'm gonna move a little faster. Just do this. And that's often the way for these manual refactorings. Do it a few times manually and slow. And then once you trust your pattern, you can go a little faster. I'm just leaving a couple blank lines between each thing to make these kind of stand out a little more when they're part of the same parser, the same grammar. Somewhere I had one that was just tokens equal. Okay, let's make sure everything is on track. I wish my IDE would provide me a semantic version of this refactoring. Like if it warned me when I moved a statement up a line that, oh wait, those two could interfere, I would really like that. Unfortunately, I'm using Xcode, it's way behind IntelliJ and even AppCode. I should probably take a look at AppCode one of these days. Are you okay now? Yes. Print, we're getting there. A nice easy one. Okay, assign parser was already there, and then this. Okay. Okay. We'll let that be. Cannot find on parser. Oh, did I delete it? Ugh. Okay. This should all just work. Good. Okay. So this, I really like to initialize. Well, okay, let's see. Maybe I do one more step. Okay. Now, all this, that's input. Okay. So all this stuff defines my grammar. And this is very close to what the actual grammar would look like. Match next, match variable. It's pretty close there. Okay, so what I want to say, my statement, read, okay, I guess that's the end. Yeah. Okay. So let's define statement parser equals, well, it's one of these, or it could be a data parser, or a define parser, dim for go sub go to, or dim parser, or dim define for parser, go sub parser, go to parser. I can go around here. If input let next on print, and return we covered as a one-word parser. Okay, and we're doing statement right now. And assign is the variable one. Variable is assign parser. And let's see what's going on with dim parser. Whoa. Did I lose one? Sure enough. Okay. Dim. Oh, dim parser returns that. Well, let's rename this. Go back up to statements. If go to go sub for define. Where's our statement? Okay. Now why are you green? Assign parser looks okay. Where's that dim parser? Did I delete it? No. Okay. Back up in statement land. Whoops, I don't know what that was. Huh. Well, okay. Find statement. Okay. Now we have statement parser. Okay, never used. And then the last bit is this case, and we have a default, a thing that gives the error message if that fails. So this should be % error message. Okay, so you match a statement by matching one word statement or one of these other ones. And I don't know, maybe this would be a little better up here. Assign parser. I still don't know why that's green. But okay. Anyway, you match any of these statements or it calls unknown statement. Now, let's make sure tests are green. I haven't screwed up anything, but I think we're okay. Okay, so the big thing we did was create statement parser. Okay. Now we want to use it. Okay. And at this point, okay, result, every one of these parsers, except the error one, produces a result. So we should be able to well, we basically should be able to say return try wrap new self statement parser dot parse. Okay, and all this should be covered by that. Okay, did I say result equals? No, I just said return. Okay, so that's our big step, and there may be somebody's behind here. Okay, there may be differences in error messages. That's the one piece I worry about, but it should work. Let's make sure the build's clean. Okay, what's your problem? Read parser was never used. Well, that's a good message. Okay, we'll run tests. Okay, and I just want to demonstrate that if I had totally forgotten it, more tests would fail. Yeah, okay. But as it is, we've got these two. Let's see what's going on. Unknown statement. Yes, this is the kind of thing I worry about. Unknown statement. All right, I think we'll do what we did yesterday. We'll just mark these. Yeah. Okay, instead we're getting unknown statement. And again, it's this backtracking parser. It gets here and it just goes like, I don't even know, you know, this is wrong. Now, the question in my mind is the parsing failing? Did we parse the expression, which string by itself is a good expression, and then we failed on the numeric type issue? Or did something else go wrong earlier that makes it say like, it doesn't even look like a def statement because it's just weird, you know? But we will investigate later. And this is unknown statement. Now this one's interesting to me because it seems like the other two got caught. Oh no, it's just catching up. Okay. I thought it ran the whole thing. Okay. Now I believe all our tests should be okay. All right. So switch to statement parser, but note a few error messages changed. Just a couple, but annoying. Okay. So like somehow we want to convince it that detecting the error here is a lot better than detecting it here. Okay, so you should be making this may be an error in our parsers too, but I mean we did check something. But when two alternatives one of the if an alternative fails at position 10, and then the second alternative fails at position 4, we want to keep the first failure as the failure for things. And then only if if everybody failed at 0, then we want this one. So really, if it truly is an unknown keyword here, then that's an unknown statement. Okay. But this is a big milestone, really. We're almost, there are two big parsers, right? There's expression and statement, and we just got statement done in our new style format with, I mean, what is this? 100 some lines of grammar definition. Okay. What I want to do now is pull out the definition of statement parser, which requires all these. All right, let's go back to our constructor. Yeah, so up here, we don't have statement parser yet, but it goes bind. Input is tokens and output is statement. And we'll just start with a bind. Okay. And then I think just like this one, that was big enough. We're gonna do that. I don't know why a sign parser. It's used twice, so maybe that's why we did that. But all right, let's do statement parser dot bind. Make statement parser. Okay, and pull this stuff out into make statement parser. Okay, so we'll take all this. Now it would be nice if my extract method actually worked. Of course not. Okay, I'll copy. Make function. Make statement parser. Takes nothing, produces a parser. And we'll return statement parser at the bottom. Okay. Now who's complaining? Make statement parser returns parser. Let's see. We had make expression. Returns. Oh, we can do a bind. Okay. And it's returning statements. Okay. And our type. Well, is that right? Okay, let's find that make expression one again. I think I did it the same way. Yeah, okay. Token statement. And do we do a bind? Yes. Oh, maybe this is because it's a field already. Okay. That should be good. Then up here, cannot convert value. Okay. This type bind token statement, that seems okay. Oh, dot parse. Gotta pass the actual method. Okay, and then this, I don't think we need that, but let's make sure this works first. Okay, so build. All right, we're not calling it yet. Okay. Find make statement parser. Okay, so that covered all this. Let's get this duplication out of here. These down to that last line that does all the work. There. Okay. Now this should reference back to that, which we have set up here. I think I can inline this back into our thing. I don't think we need to bind it. That was just because we hadn't unified all the grammar. All right, that's a big step. Okay. Extract make statement parser and use it in initializer. Okay. Let's pull this back out. Okay, let's see who uses this. That's probably the first thing. Okay, we set it up here. We set it up in the constructor. We reference it in the let statement, and we reference it in the variable. Okay, so I'm pretty confident I can move this thing out of here. Cut this, delete this. And put it up here. Assign parser. It's used in the let, it's used by itself. Okay, this should pass. Okay. I also wonder about comma variables parser. let's see who uses that. Okay, we define it here. We create it here. We reference it in prompt plus, which is part of the input statement. Reference it twice. And we use it in read. So yeah, once again, I think we don't need that. Comma variable. Parser. And the references are down here. It's kind of a generic thing. And test. Okay. So now this big horrendous parser is defined in one place anyway. We call it once in our constructor, and then we're good. Okay. All right. That's a big step. Now, I think we're ready to move this up a level again. Okay. Oh, wait. We've got all this stuff. That's all make, right? Make statement parser. But statement itself, wrapped new. Well, who calls statement? Okay, we wrap old statement in line. Statements parser wrap colon. Okay. Statement is defined. It's referenced in if statement. Okay, let's see. I think we need to. Okay, so bind, it's legitimately referenceable here. And we're binding it after that. So this is allowed to reference the variable. It's created up there, but it's not bound up there. Okay, so this one should be able to call statement parser. Okay, I don't think that affects anything else, so let's see if that works. This is the mutually recursive function, so it's tricky. That's why you have that little dance with the bind. But we have like two of those. We have expressions can ultimately refer to expressions, and statements can ultimately refer to statements. Okay, so make if statement reference the new style statement parser. Okay, so that's cool. And then I want to inline this. Who's calling this? Well, I just had it there. It's called in one place. So we can copy this inline this there. Okay, so wrap old statement is wrapping a new statement, so let's just use statement parser. Okay. Okay, let's make sure that works. Okay, refactor inline statements method. Okay. Right. All right. I think that covers the statement. We've done this one. So let's make this statement is done. Now we're looking at statements. So we're trying to get the rest of our old style parsers. Okay, this is lines. Here's statements parser. Let's go see that thing. Oh, that's right there. Okay. Okay. So this is another exercise in wrapping. Okay. Let's take a break. It's maybe a touch early, but this one's complicated enough. I want to make sure we have a break first. Okay, so we'll take about 3 minutes and come back and see if we can get this line method working. Okay, welcome back. Let's see. During the break, I thought, hey, I wonder if we're calling wrap old anymore. And it looks like we're not. Okay, so that's a noticeable step that we got through. We'll go and delete that shortly, but I want to try and get this line parser converted to the new way. We've only got, well, I don't think we have a lot of places calling wrap new either. Let's see, wrap new. Here, data parser. Does anybody call this? Nope. Okay. And we're back around. Predefined function call. Okay, I'm gonna come back to that one. We're doing line. Line. Okay. All right. So a line, it matches a line number with semantic check. Then it matches statement. I guess a line is followed by statements, which is this. And if it doesn't match end of line, it gets that message. Okay, and then we return a construct out of it. Okay. All right, so this is line parser. We're going to match a integer. All right. I guess we can pull this up. Okay. So we match an integer. That's all semantics. we match our statements parser. We don't need to keep the other. I guess I can inline that here. Match a statement parser. And then we match an EOL. And I can borrow this. And this is a left match. We don't need to keep the EOL. We just need to match it. Okay, line parser never used. This one we inlined. I think that's okay. Okay. Right. So, well, we don't produce a parse. Okay, we'll need a semantic function. So let's get that thing in. It's got to validate, and it's got to produce the new type. So that's one of those kind of check functions, I call them. It's a function, make line, and it takes, well, what's it take? It basically, we match, we need to keep the line number too. Okay, so we need both the line number and the list of statements. Okay, I'll get there. Well, let's call it argument of type. This should be a token, and the second one is an array of statement. Okay, and then we're also going to get the remaining, which is array slice of token. And we produce a parse result of token to parse. Okay, now what's expected body missing return? Okay. And this, I think it's ampersand greater make line. Okay. The return, well, we need to do this stuff. Okay. Let token expers equal argument. And then line number is token.float. If this goes wrong, if it's out of range, we don't throw, we're going to return a failure. Token index of token, and then I'm going to say we have to add 1 to that. It's really the thing after. Well, let's try it without, but I believe we're going to have to add 1 to it. It's a failure it shouldn't be a column 0 failure, basically, and it will be at this point. Okay. I guess +1 is okay, because the worst case we got an end of line there, and that's okay. Okay, line number must be between those ranges, and we did a failure. Okay, so that's that. Now that gets dealt with in our parser, so this is what we need. And I want to make sure the type of this is, well, keep left. It's going to be an array of statements, so I think we're okay. So we'll return a parse with the line number and the, oh, these aren't expers, they're statements. Oh, it's a success, yes. Success with this and remaining. Okay, that should build. We're not using it, so there should be no change. Okay, define new style parser for line. We're not using it yet. Okay, and this is return try wrap new line self line parser dot parse. Okay, and that should replace all this. Oh, I did something wrong. Oh, didn't go far enough. Okay. We probably need this message. And I don't think we won't get quite the same message. I think line numbers required. I think we'll just do that. We won't say the token, which I think is a little goofy anyway, because those names of tokens don't mean anything. Okay. Oh no. How's that look? Okay. Yeah. Okay. Right. So I've changed the message a little bit. If that's the only change, I will take it. I also think there may be a risk around like end of line. One failure, no line number, found remark. How about at start of statement? Good. All right. Make line, use new style parser. Let's clean out this. Who calls line? Well, that's single line. Single line's not doing a lot there, is it? Okay. Try line. If it's a parse error, return this. All right. I think we can inline this. Okay, try line. Let's put the inlined in. Line parser equals that. Return try wrap new. Okay. Oh, I'm way behind here, aren't I? Okay, new return parser we did. Replace other old parsers. So statement, statements, line. That we did. Okay. Make single line deal with new style failure. That's what I think we're up to now. Okay, we did this. Oops. Okay, so single line. I guess it's the method. Okay, that's more like it. Okay, so it calls try wrap new dot parse. Okay. Yeah, this thing should. Okay, well, let's just do it. All right, so let's. Can this be defined outside? Statement parser. Yeah, I think that can be defined up here. I'm gonna change this name. Okay, I'm gonna change it manually. This is var or array. And that. Okay, now we got statement parser. Oh, I just. Yeah, I just screwed that up. Line parser, I'm moving up. Like, do one thing at a time. Line parser. Just say line. And then we're going to define a line parser. Produces a parse. And we'll bind line parser dot bind to line dot parse. Okay. And then this, let's see if it's woken up. No. Okay, this is var or array. And there. Okay. Now back to single line. Okay, he should be happy. Line parser is defined at the top now. Okay, good. Let's check that in. Move line parser to field. Okay. So now instead of wrapping the line parser, I just want to call let result equal line parser dot parse of input. I guess that's of tokens. Expected expression cannot convert. Well. Okay, so we got a result, and then we can switch result. One case is a failure, position message, and the other case is a success with parse and remaining. I don't know if I have to say let on those. Okay. If it fails, fix these two. All right. If it fails, what do? Well, we find the error token and the message, and we return a parse. Error token is hard to know where that comes from. We don't know the line. Okay, so interesting. Parse with error token dot line and error message. Let's punt on that slightly, and we're just going to return a 0 for now. 0 with error 0, position and message. Okay. This would represent the line number. I think we're going to have to extract it if we can. Okay. And then if it's successful, well, that's easier. We checked that it matched the end of line, so we're only matching a line at a time, and we're returning a parse. Well, let's return parse, and this we will ignore. Okay. And yes, that will never be executed. I'm fine with that. So this should fail any test that looks at the actual error line number, which many may. One failure that really checks that. Okay. 10-7. Yeah. Okay. We can pull the line number. All right. Whoops. Syntax analyzer. Yeah. I mean, we have the tokens. let error line equal if token sub 0 dot type is integer, then we want to use token sub 0 dot float. Otherwise, we don't know it, and we use a 0. Okay, and so let's use error line here. Okay, a little goofy, but I don't think it's a type mismatch. Does need to be int. Yeah. Line number. Okay. Yeah. I think that should pass our test. No. Interesting. 10-2. Oh, okay. The 10 is right now. The position is not right. The position is the token position, so we have to use index of. Okay, I get there eventually. Position cannot convert value type int. Index of token at position. Tokens. Okay. Oh man, am I still off? Extra characters at end of line. 10-2. Okay, let's get this separate. Let error column equals it's token subposition dot column. Okay. Okay, because each token knows its position, so if we know which token had the error, which we know from this, we should be able to get the column out. And I know I've said it before, but it's kind of like the error handling is harder than the real work. Okay. But that's all right. So this can go. Okay. And let's see how we're doing. Okay. Move single line to new style parser. Or maybe that's change. Okay, so this gets called there. That's fine. Line parser.parse and a switch result. Get the position, get the message, find the line number, and good. Make input statement. Okay. Now, let's find these wrap news. Okay, who are you? Predefined function call. That's the only occurrence. More wrap news. Delete me when the wrappers go away, so make sure nobody's referencing this. Should be parser tests. Yeah, so the wrapper tests use them. Okay, but nobody's calling wrap old anymore, and nobody's calling wrap new anymore. So these tests go away. Make sure this is only, those are checks. Test wrap new, wrap old, wrap old. Oh, these are, okay, those are legit, but let's get these wrapper tests out of here. Wrap old, wrap new, okay. Does anybody reference this? Yes. Okay, anything else? Check one statement. Okay, so now this should be unreferenced. Find in workspace. I don't know how you think that's there. Okay, let's try build. And then a find. See if it updates. Oh. Okay. Require variable. All right, so delete did code require variable. Okay, so what's my to do? I guess, yes, we did this. And we are delete the wrappers. Yay. I believe that's where we are. Okay, and where are those wrappers? Here's wrap new. Here's wrap old. Okay. And I don't know if I can do it. I'll just do a hard copy for myself, just just to preserve that much. But I've got it in Git. Let's delete this. Remove the reference. Okay. All right, we're down to 300 tests, but the wrapper is gone. Okay. We're strictly on new style parsers now. Okay, so that is great to be here. All right. Now we got leftover work. Okay. Basically I kind of want to deal with this one. These two I may not want to. Okay. We left things I don't know. I would say the order of functions and all that is a bit crufty at this point. There are things that are going on. Um, well, like we got these things that make parsers. That's kind of one group of stuff. And then we have these require types, and some of those are probably not used. Some of these semantic functions, they kind of, um, yeah, they're very custom to the statements. Okay, but I would like to organize them. These check methods, they're something. Okay, um, this is kind of, I don't know. All right. So, trying to think what would. Oh, the other thing going on. Um, we introduced a new checker kind of thing that combines these two, or, well, it can. It's a better signature, I think. Okay. I'd like to unify that. I might be able to pull expression and statement into their own file. I would kind of like to do that if possible. Um, these, I'm not sure all of them are being used even. Okay, so let's, let's pull the make functions. And I think I don't know. I think they're awfully. I mean, it almost could live on expression. Some of these, they're very custom in their argument types, though. I mean, that's all based on the rules we're matching. Okay. Yeah. Let me tell you what. Let's pull the make methods to the bottom. Okay, and more or less alphabetical. Okay, so just kind of a rearrange the file sort of thing. And after we get those done, maybe we'll see about pulling parsers outside too. The next token, does anybody reference this? One place. Require. Does anybody reference this? None. Good. Okay, so we can let's get rid of dead code that we see. Maybe that's a good first pass. Okay, and we used those in our old parser. Single line we use. Okay, here's a make. Make line, make input. Okay, that seems good. Pull those down. Make line for dim for. Make line input comes a little sooner. Oh, that's a make parser. That's different. Make data. Make dim. that. Breakpoint. I know there's a way to fold these things. Fold. Oh, let's do that. Yeah, that'll help. Okay. Match require if statements. What is that? Require make the parser. That's different. Make binary. Well, these are all expressions. Maybe that's. Oh, whoops. We'll just make our own little region for a minute here. Make expression methods. Binary relational number. Whoops. Predefined. Check we're going to put somewhere else. Okay. Statement data dimension. Okay. Hit everything. Control. Oh, Alt, Option, up arrow. User-defined call is a expression one. User-defined call. On statement, print statement. Those are generator types. Well, it's really a check and generate, isn't it? Okay. Type 4. Require. Make expression parser. Okay. Require. Check. 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 Okay. Make sure it all works. Okay, now these check functions. Where's my makes? Make statement parser. Where's make expression parser? Folding, unfold. Well, that didn't seem to do it. Okay, token to simple statement. All right, who references this? Oh, okay. I don't know, these index of, like, one of, this can be defined at the top level. Well, match, those can go up top. I don't know. I'm trying to, this file is just flat out too big. It's smaller than we had to start with, I think. I don't know. After all that, maybe it's not. I think it's easier to read these parsers. You have to kind of get your head around the operators, but once you do, I think that is very straightforward. Okay, but this, like these, I feel like we might be able to promote them into our library. I'd have to generalize over this, and the message would have to be made more generic. Maybe that's generic enough. Token description. But that's generic enough. I can go in the library. I think both these, they're close to being generic enough. Maybe they're not quite. If we abstract over token type, we don't care what the input type is. Matching out of a set, that's probably not feasible. But doing a direct match just requires this. Oh no, that is. It's not quite going to work. Because token type, it's our input is tokens, but yeah, we're looking at tokens when we parse things, but I'm looking at token types when I run these methods. So they are pretty specific to this. Okay. Yeah, I think they are. Okay. Excuse me. The expression parser, I would love to pull that out. I think, well, let's look at it. Okay, it works its way from the bottom to the top. You can make a parenthesized expression. You can get a number. You can get an integer or a string. Okay, predefined function, user-defined function. And then factor. Yeah, so factor is either parenthesized expression, number, integer, string, variable, predefined, or user-defined. Okay, and that's good. Once you have factor, you can raise it to a power. You can negate it. You can multiply or divide. You can add or subtract. You can compare. You can take not. You can do and. You can do or, and that's the top level. Okay, yeah, that's pretty good. This, we can make this better. Maybe that's the next thing to look at. Because we introduced that new approach that just pipes it through and can optionally transform it. Now this is the same across all of these binaries, so maybe just checking it is better. But let's see, we can find require float type. Okay, these are all that. Let's get through definitions. That's an old school one. Yeah, we got multiple versions. Okay, one is 415. Let's move this up. Okay. Yeah, so require float type. This one takes an expression and the remaining and verifies it and returns either success or failure. This one checks for number and throws a parse error. So I don't think anybody should be using this one anymore. Ooh, okay. They are. Okay, that's interesting. All right, and then I thought we saw, let's look for another one. Require float type, 425, 447. Okay, right. We got three versions of this around now. We've got this one that's the original, and is that the one I just searched on? Yes. Okay, so that's the original. It's used 4 times. We've got this one that was sort of the way our parser library uses it, and it's in these. Okay. And it's used in expressions. And then we've got this one that's the newest way. And it's used once. Okay. And if it succeeds, it just returns the expression it started with. So it's suitable for pipelines. Okay, and it's used with this bar ampersand greater. This one, yeah, I think this is the one we want to get rid of. So I think I can do bar ampersand greater. And same thing here. Bar ampersand greater. Okay, so that, whoa. Can I convert value of expression array slice of token? to expected target, aka array of token. I mean, maybe it's parentheses. I don't trust it. Build again. No. All right. Smaller byte. I know I did some rearranging and maybe some other stuff too, so let's see what we got. Rearranged. 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 Yep, move that up. Yep, pulled the required float types together. Okay. Okay. So let me find my pipe creator, pipe ampersand creator. Okay, require matching types. Check def. Require float type. Okay. So you got to give me an expression. Yes. He wasn't an expression yet. Okay. Try again. Require float. Types. We just want the singular. Okay. I think I need to change the order of these. Make it an expression. Then pipe it to require float type. Wow. Extra characters and line. Okay. Let's go back. How did that mess up everything? I'm confused. What's this thing doing? Oh, he knows his types very well. Tokens and expressions. Okay. It produces int string optional. Require float type. Okay, I'm going to move this one out of the way. Okay, give me an expression. Yeah, this is interesting. Okay, so the expression type, we're really wanting to do it on the first. Well, the difference is this one, this list of tokens is all the minus signs, say, that are there. And then expression is the bottom level expression that should be a float. Um, let's focus on a different one. Find these ones that were used here. Okay, this is check def statement. Token expression. Okay, well, one thing I can see is we can do these in one statement. I don't know if I see any others like that. Left. Token right could be nil. Okay, that one doesn't apply. Same thing here. Number just takes a token. Token right could be nil. Okay. These optional ones kill me. Alrighty. Yep. Deconstruction. This one. Okay, make for statement. Variable equals expression. This, I would like to do it here. Type. Expression parser require float type. Let's, oh man. Invalid conversion from throwing function of type expression throws nothing to non-throwing function. Oops. Okay, so expression parser yields an expression. This checks that it's actually a float type. Let's see if this blows up. It should not. Oh. Unknown statement. Oh. Okay. That fixes something. That's good. Okay, so now where'd it come from here? Oops. for statement. Initial, I'm doing that up there. Okay. Now that should still fail, but we can fix those messages. We want to fix those messages. Numeric type is required. Okay, and I think the other two are still failing. They're still unknown statements because we haven't done them yet. Okay. Yeah, this is good. All right, go back, go back. Well, how about, whoops, find for parser. Maybe that's this. Expression, yes, okay. To an expression, pipe that to require float type. Okay. And then this one also. Require float type. And now this can't happen. Or, yeah, we would have already gotten the error before we got down into here. Okay, so there's no point checking it here. And we should get those two failing tests that complain about the error message. Good deal. Okay. And that goes away. Extra characters at end of line. Oh dear. Yeah, that's a tricky one to get past. So I guess the to-do still holds. We'd prefer numeric type is required for illegal step. Okay, but do it pass? Okay, use new style require float type in parse statement. Remove. Fixes a couple error messages. And maybe if I can figure out this parser issue with this. So I think what should happen, extra characters end a line. I mean, I think the parse is somewhere in here, maybe even here. Yeah, my interpretation is it should do this part that's required, and then it does the optional step X, and then it type checks it here and says, oh, wait a minute, that's a string. That's numeric type is required. But then, and so the parser says, well, I guess that phrase didn't come in. And it's not an error. I mean, it was an optional phrase anyway, and it didn't find it. So I think it says you had 0 occurrences. That's fine. And reports the error here because now it's at the end. It supposedly parsed the whole for statement and it finds a step. I guess the question is optional is kind of like, we kind of want credit for getting as far as we get in an optional. That's the problem. Now, in an alternation, we say we could accept this or that. Yeah, it's a puzzle to me. I don't know if you can. I mean, normally if you say, okay, let's put some text in. All right, if I say match A or B, let's match A or B A. If you come in with AB, we should die at the second A and say, oh, you didn't match that. And then we match BA, we fail right away at the 0 position. And so at the end, I mean, I think we should be saying you failed to match at column 1 on that first rule, so that's where you failed. And then all else equal, you would normally have a percent there at the end to say, if you came in with a C, unknown start. Okay, so if you came in with AB, you would fail here, position 1. If you would then back up and try the next alternative, BA. Well, I don't even match the B. Try the next alternative. This doesn't come into play because, this only comes into play if everybody failed at the front and you didn't. So this should be the message. Now, optional. Let's change it around a little. Let's say you're looking for A or a B. If you come in with AA, you're fine. AB, you're fine. AC, you've matched the A. I would expect you would probably come in, you'd probably say B was expected at that point. Now maybe it should be, if they all got the same distance, then you do this. And that, let me make a note of that. To do it, for alternatives, should default message apply if they all got equally far? Okay. That's a library question, I think. For us, okay, AA, if you came in with B, you definitely trigger this. If you came in with AC, you probably get dinged here. Because you got as far, if they're equal, we take the later one. Okay. Now, if I do an optional, okay, A optional A or A, B, and percent, whatever. Okay. Now, this is really the same as A empty or A. Yeah, and I guess that's the issue, that empty passes, and so the construct says I passed. Don't worry about me. Even well, actually, it's treated more like this. It's treated more like A or empty. Okay, and if you come in with if you match A, good. If you don't match A, well, at least empty matches. And same thing, to be specific here, if I match step and then string, okay, step and then number, okay, the step matched, the number didn't, well, rule, the first part of this rule failed. We try the second part and it succeeds and we're happy. But we kind of shouldn't be happy. Because the failure okay, in our case, let's put the rest of the 4. We'll ignore all the junk in 4x equal 1 2 10, that stuff, but that part parsed, and now we have this, and it, if you got past the 4 and then you got past the empty, that was fine. But now we have characters at end at this position. I don't know a good solution here. Because the point of the empty is you should be able to pass. The only thing I can do well, okay, another way to handle this is called error productions. Okay, and the idea is you muck with your grammar to allow things that shouldn't be allowed, and eventually catch them. So I guess the change for this would be like make it be 4 step. Oh no, it's still got to be optional. Okay, yeah. 4 is legal, or 4 step, and then followed by expression optional expression. Well, no, yeah, optional expression. Okay, so now, when I process, yeah, can I make this work? This looks legal if I have 4 without any steps at all. Okay. Then this side says I succeeded, and it doesn't even need to try this one. No, it's not quite right. I guess let's let's swap the order. Okay. Or 4. Okay, I think I'm onto it here. All right, now you try 4-step optional expression. If you succeed there, I think I'm testing a different error, aren't I? 4-step expression. Yeah, I think the error case, okay, would be this one. Whatever the check is, require floats. Okay. Now, let's see, we're getting there. 4-step expression or followed by check. This, I mean, this whole thing is failing. At the check. And yet when it comes in, because it's got alternatives, this one is also check, isn't it? In check it. Okay. Yeah, so I think what this would be this. The error production would be we add 4-step expression. And then 4 without a step. Okay. And then if this one happens, you still need to detect it. Okay, let's go back a version. Where's my 4? Was it make 4? Make 4. This thing. All right, let's look back. Let's go compare to this. Get down here. Make user. Make 4 statement. Okay, let me pull this code back. We took out the initial and the final. Let's take out the step. Let's leave in the step. Sorry. Okay. Failure index of token message. Okay. Numeric type is required. Okay. And then in the 4 statement itself, let's take out this one. So I'm saying we'll enforce that one in the make 4 statement. Was that working? I don't even know at this point. Unknown statement, extra characters in a line. Okay. Well, I think extra characters in a line is better than unknown statement. Unknown statement says, I don't even recognize this as a 4 statement at all. and the extra characters is going to point at the step and say, I don't know, something's going wrong here. I'd far rather point at this and say numeric type, but that tells me this rule this thing is making it blow up before where's it doing? It's blowing up. It's kind of negating the whole thing. The whole statement fails. Where's this token? Wire float type. Oh, token is not a meaningful thing. Okay. Okay, so what I did was an improvement. It's not the ultimate, but yeah, we can't talk about token. This is the one that throws. Okay, let's go back here. Throws parser token. Yeah. Okay. Okay, this comes back out. Make for statement and require float type. Okay, so this is we haven't done it yet. Require. I'm trying to get rid of require float type. Okay, this one. Who calls this? Whoops. Find usages. It is called on check def. Okay, require float type expression on check def. Okay. This was another weird situation. Okay, require float type. So I check def, and now this is no longer happening. That and then type, it's on my list. One failure. Okay. Numeric type required. Good. Okay, so that's a progress. Okay, let's delete this dead code. Make sure. Okay, so we remove use of require float type. Old require float type. Improves error message on def. Okay, and require float type. This one I think is no longer used. Right. Okay, now the situation is this. I'm back to this one that threw me off last time. Okay, so require float type. It takes tokens and expressions. If tokens is empty, it's not a problem. If the expression type is numeric, it's not a problem. Right, but this one takes an expression. Okay, so who uses this? I think it was all those statement expressions. Negation parser and not parser. Yep. Okay. Now, what's going in is the match minus. So, So that's an array of tokens, and that if I just make a unary expression, does that work? I should get an error message that fails, but it should mostly work. Numeric type is required, was not reported here. Okay, that's legit. Okay. And I guess I'll just check the not for the same thing. Again, I think there'll be one test that doesn't pass. No error found. Okay, yeah, that one. But what about this negate? Not. It's like I don't have a test for that. Let's find tests. Not $. Oh, that still passed. A equals not $. How does that pass without this? Does it make you recheck it as well? No. Let me run those tests again. 2 failures. Okay, that's what I expect. Where's the second failure? I think it's... Let's comment this one out and make sure it's down there. Should be line 379. Yep. Okay. Xcode's getting a little flaky here. It's supposed to run all the tests. It's supposed to keep going when it finds a failure and then report everything at the end. Okay, but that says... Okay, so both these are required. Okay, so I think what I should try is this. Power parser must be a float type. And that should take me to the other one. Yes. Okay. Go back. And this one out, theoretically. The world falls apart. Okay. Why? Power parser must be numeric if it's going to have a minus sign in front of it. Oh. Oh. Yeah, these are all the ones with strings. Yep. 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 Okay. Okay. This may be one where I could say it's either a power parser or it's one or more match minuses. This one doesn't require float, but this one does. Let's try that. I think there may be a case. Is there a fall through case that might fail? No? Okay. I guess not, because these two, if something failed, this is equivalent to what we had, that we allowed 0 minuses in a power parser or one or more minuses with a float. Okay. And we checked if the token list was empty. We didn't do the error checking. Okay, so let's do the same thing for not. It can be a relational parser or a bunch of nots followed by a relational parser, pipe to require float type. And this one goes away, and make your expression. And make sure that's simple. It's got the tokens, it returns it, otherwise it applies them in reverse order. Yes. Okay, that should pass too. Okay, and let's look for require float type. Okay, and then who's calling this one? Nobody. Okay. Test should pass. That's a refactor at this point. Remove dead code. Require float type. Use the most modern one instead. Okay. Well, let's go to our to-do. Require float types better attached to expression types. I think we've done that. We only use the newest check style. Okay. Improve messages on to-do tests. Well, we got some. I think the next thing to do, yeah, we got all these require float types. Okay. Unify all the require float types methods to newer check style. All right. Very good. All right, so we hit a big milestone. We fully replaced the old style parser, and that's a big deal for us. That's kind of the big evolution we set out to do. Now I'm in the more cleanup-y stage. I kind of did 2 ways or 3 ways of doing it, and let's get it down to the one way. And then at some point, well, this, yeah, that's pretty much what that's gonna be. Okay. Um, we have the same thing for require matching, require float types. Okay. Let me just pull this one up next to the others. Okay. And anyway, we'll pick up there tomorrow. It's 10 a.m. Eastern Time to 12:30 p.m. or 3 to 5:30 p.m. UTC. And been a good session today. I'll just check this in off camera and call it an afternoon. And enjoy your evening. Thanks for joining. Bye-bye.